Hi guys, in today's video we're going to talk about the definite integral. We'll jump right into it by defining the definite integral, which is written as the integral from a to b of f of x dx. And it uses this symbol, the integrand symbol, which is actually a stylized s. The definite integral represents the area under the function f of x between the values x equals a and x equals b. As we previously saw, this area can be represented as a sum of infinitely many infinitely small rectangles. In the first version here, we've got the limit as delta x approaches 0, so the limit as the size of each rectangle becomes smaller and smaller, of the sum of all of the individual rectangles, f of x times delta x. In the second version, it's written slightly differently. It's written as the limit as n goes to infinity, so as the number of rectangles becomes infinite, of a sum of f of xi delta xi. Both of these encapsulate the same idea, though, that we previously stated, that we get a perfect representation of the area under a curve if we take the limit of separating it into an infinite number of infinitely small rectangles. For now, we will be approximating the integral as a sum of n finite number of rectangles of height f of xi, the value of the function at that point, multiplied by the width of each rectangle. We'll now look at a few properties of the definite integral that will become useful in future lessons. The first definition is that the integral of k f of x is equal to k times the integral of f of x. The constant in this case doesn't affect the integration at all, so we can take it out the front and perform the integration as if it's not there and then simply multiply by the constant at the end. The next property is kind of obvious. If you add up all of the area under the curve f of x from a to b, and then add up all the area from b to c, what you must have is the total area from a to c. The next property says that if we've got the integral of the sum of two functions, f of x and g of x, that the area under that sum is just equal to the sum of the two areas, so the sum of the area under f of x and the area under g of x. The last property is that if we switch the limits of the integration, so if we have the integral from a to b and we make that the integral from b to a, we get the negative answer. These individual rules can of course be combined in various ways to give us more complex behavior of the definite integral.